First, according to code requirements, it is indeed possible to derive a single-phase service from a three-phase panel. However, it's essential to be aware that certain restrictions and wiring specifications must be strictly adhered to. A valuable resource for understanding these requirements is Article 408 of the National Electrical Code, commonly referred to as the NEC. Article 408 provides comprehensive details regarding switchboards, switchgear, and panel boards, offering guidance on installation, wiring, and safety standards. Secondly, when it comes to assessing whether the existing service drop possesses sufficient capacity to accommodate the additional load of a new meter and panel, it is crucial to consult Article 220 of the NEC. This article serves as a guide for calculating branch circuit, feeder, and service loads in electrical installations. Within Article 220, you will discover two primary methods for determining the load requirements of a building. The first approach involves calculating the total connected load of the building. This entails meticulously accounting for all electrical loads, including lighting fixtures, appliances, equipment, and any other devices that draw power. When performing this calculation, be sure to reference Article 220.30 and 220.31, which provide detailed instructions on how to accurately determine the general lighting loads for various occupancy types. These articles offer specific guidelines for calculating the minimum lighting load based on the square footage of the building. Additionally, you'll need to consider the loads imposed by appliances and other equipment. Article 220.50 through 220.54 offer guidance on calculating appliance and equipment loads. This involves determining the volt-ampere rating of each appliance and applying any applicable demand factors or diversity factors. Demand factors are used to account for the fact that not all appliances or equipment will be operating simultaneously at their maximum load. Diversity factors are similar but are typically applied to entire groups of loads rather than individual appliances. The second method for determining load requirements involves calculating the demand based on Article 220.41. This approach takes into account historical data and past experience to estimate the directed connected load. In other words, it acknowledges that the actual load and the service drop may be lower than the sum of all connected loads due to factors such as intermittent usage and diversity. To utilize this method effectively, you'll need access to historical billing data or load monitoring data for the building. This data will allow you to analyze the peak demand and average demand over a specific period. Once you've gathered this data, you can apply appropriate demand factors or diversity factors to estimate the derated connected load. After calculating the demand using either of these methods, the next step is to compare it to the capacity rating of the service drop. This rating is typically expressed in amps and can be found on the service disconnect or meter. The service drop's capacity must be equal to or greater than the calculated load requirements. In other words, the service drop must be able to supply enough current to meet the building's electrical demands without being overloaded. If the calculated load requirements exceed the service drop's capacity, you'll need to upgrade the service drop to a larger size. This may involve replacing the existing service cable, meter, and service disconnect with components that are rated for a higher current. Finally, in terms of pricing the job, it is strongly recommended to seek guidance from a local electrical contractor. These professionals possess in-depth knowledge of local code requirements and the prevailing job market conditions. Their expertise will enable them to provide you with a fair and accurate price for the project, taking into account all relevant factors such as material costs, labor rates, and permit fees. Furthermore, consulting with a local electrical contractor can help you avoid costly mistakes and ensure that the electrical work is performed safely and in compliance with all applicable regulations. They can also assist you in obtaining the necessary permits and inspections, which are required for most electrical projects. Remember that working with electricity can be dangerous, and it is always best to leave electrical work to qualified professionals. Attempting to perform electrical work without the proper training and experience can result in serious injury or even death. Additionally, improper electrical work can create a fire hazard or damage electrical equipment. Therefore, it is essential to prioritize safety and seek professional assistance when dealing with electrical systems. Furthermore, When working with three-phase systems, it's vital to understand the voltage relationships between the phases. In a 240-volt three-phase system, the voltage between any two phases is 240 volts, while the voltage from any phase to neutral is approximately 139 volts. This voltage imbalance can cause problems if you attempt to connect single-phase loads directly to the three-phase system. To avoid these problems, it's essential to use a step-down transformer to convert the three-phase voltage to a single-phase voltage that is suitable for powering single-phase loads. Additionally, when installing a new meter and panel, it's important to ensure that the wiring is properly sized and protected. The size of the conductors must be adequate to carry the anticipated load, and the circuit must be protected by overcurrent devices such as circuit breakers or fuses. These overcurrent devices are designed to trip or blow if the current exceeds the rated capacity of the circuit, preventing damage to the wiring and reducing the risk of fire. Moreover, it's crucial to properly ground the electrical system to provide a safe path for fault currents to flow back to the source. Grounding helps to protect against electrical shock and reduces the risk of fire. The grounding system must be installed in accordance with the NEC and should be inspected regularly to ensure that it is functioning properly. In addition to these technical considerations, it's also important to address any aesthetic concerns that may arise during the project. For example, you may need to conceal the wiring in conduit or raceways to improve the appearance of the installation. You may also need to paint or finish the electrical equipment to match the surrounding decor. By paying attention to these details, you can ensure that the finished project is both functional and visually appealing. Furthermore, it's essential to maintain accurate records of all electrical work performed on the building. These records should include detailed drawings of the electrical system, as well as a list of all equipment and materials used. This information can be invaluable for future maintenance and repairs and can also be helpful if you ever need to sell the building. In conclusion, while it is possible to derive a single-phase service from a three-phase panel, it's essential to follow all applicable code requirements and safety standards. Consulting with a local electrical contractor can help you ensure that the project is completed safely, efficiently, and in compliance with all applicable regulations. By taking these steps, you can protect yourself, your property, and the occupants of the building from the hazards of electricity. And as a final point, always remember to de-energize the circuit before beginning any electrical work. This means turning off the circuit breaker or removing the fuse that supplies power to the circuit. Double check to make sure there is no voltage present before touching any wires or equipment. This simple step can prevent serious injury or even death. Safety should always be your top priority when working with electricity. The NEC, or National Electrical Code, serves as the cornerstone for electrical safety in the United States. It's a comprehensive set of standards and guidelines designed to ensure the safe installation and maintenance of electrical systems. Understanding and adhering to the NEC is not just a matter of compliance, it's a matter of protecting lives and property. The NEC is updated every 3 years to reflect the latest advancements in electrical technology and safety practices. It covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It's important to stay up to date with the latest edition of the NEC to ensure that your electrical work is in compliance with current standards. Article 100 of the NEC provides definitions for many of the terms used throughout the code. Understanding these definitions is essential for interpreting and applying the NEC correctly. Article 110 covers general requirements for electrical installations, including working space around electrical equipment, protection against physical damage, and identification of conductors. Article 210 covers branch circuits, which are the circuits that supply power to individual outlets and lighting fixtures. It specifies the types of wiring methods that are permitted, the size of conductors required, and the overcurrent protection needed. Article 230 covers services, which are the conductors and equipment that connect the utilities power supply to the building's electrical system. It specifies the requirements for service entrances, service disconnects, and grounding. Article 250 covers grounding and bonding, which are essential for electrical safety. Grounding provides a path for fault currents to flow back to the source, reducing the risk of electrical shock and fire. Article 300 covers wiring methods, which are the ways in which conductors are installed and protected. It specifies the types of conduit, cable, and raceways that are permitted, as well as the requirements for supporting and securing the wiring. Article 310 covers conductors for general wiring, including the ampacity of conductors, which is the amount of current that a conductor can carry safely. It also specifies the requirements for conductor insulation and protection. Article 400 covers flexible cords and cables, which are used for portable appliances and equipment. It specifies the types of cords and cables that are permitted, as well as the requirements for strain relief and overcurrent protection. Article 408 covers switchboards, switchgear, and panel boards, which are used to distribute power throughout the building. It specifies the requirements for installation, wiring, and overcurrent protection. Article 430 covers motors, motor circuits, and controllers. It specifies the requirements for motor overcurrent protection, motor disconnects, and motor control circuits. Article 440 covers air conditioning and refrigeration equipment. It specifies the requirements for disconnecting means, overcurrent protection, and wiring methods. Article 500 through 516 covers hazardous locations, which are areas where flammable gases, vapors, or dust may be present. It specifies the types of equipment and wiring methods that are permitted in these locations. Article 600 covers electric signs and outline lighting. It specifies the requirements for wiring, overcurrent protection, and grounding. Article 700 covers emergency systems, which are designed to provide power to essential loads during a power outage. It specifies the requirements for emergency generators, transfer switches, and battery backup systems. Article 701 covers legally required standby systems, which are similar to emergency systems but are required by law for certain types of occupancies. Article 702 covers optional standby systems, which are installed at the owner's discretion to provide power to non-essential loads during a power outage. Article 705 covers interconnected electric power production sources, such as solar photovoltaic systems and wind turbines. It specifies the requirements for connecting these sources to the utility grid. And as a final note, always consult with a qualified electrical inspector before beginning any electrical work. The inspector can provide guidance on code compliance and ensure that the installation is safe and meets all applicable requirements. Remember that electrical safety is everyone's responsibility. By following the NEC and taking precautions, you can help to prevent electrical accidents and ensure that electrical systems are safe and reliable.